Hello, good morning. We're in the third section. The first videos, or chunks of videos, because it kept freezing up, were the first few sections of chapter 3. So now we're in chapter 3.3. We've learned so far how to write coordinates on a coordinate plane, or graph them, I should say. We have learned how to graph a linear equation with a table of values. And we have learned about x and y intercepts, that you only need to graph with 2 points. Having more is actually better. It's a better, clearer picture, but all you need is 2 points to create a line. So we used intercepts so far when our equation was in standard form. Standard form is good for x and y intercepts. And then we learned how to write our equation in standard form. So today we're going to talk about slope. When we have a line, the gradient, okay? So the slope of a line is a rate of change, and it describes the rise over the run. So it describes how far you go up and how far over. So what is the slope here? You're going up 4 and over 6. That can be reduced. Cut in half, cut in half. What's the slope here? Rise over run. So our rise was actually down, so it's negative, and over 3, which reduces to negative 2 over 1, which is just negative 2. Okay? So it is defined as our change in y over our change in x. This little triangle here called delta is simply a Greek symbol, okay? It means, for in this instance, we're going to change what's the differences in our y values over the differences in our x values. So it is defined as delta y over delta x, or the differences between your y's, the differences between your x's. And so we don't want to just write y minus y over x minus x, because that means they're the same thing. So to make sure that we're talking about two different y's, we call one y1 and we call one y2. To make sure we're talking about two different x's, we say x2 and x1, or x1 and x2. Okay? So what is the rate of change or slope of these linear equations? So here I'm seeing 2 points on the line, and I'm going to rewrite them over here as 4, 3, or negative 2, negative 1. Now, it doesn't matter which one you put first, but if you put this one first, they both have to be 1s, and if you use this one second, they have to both be 2s. So to find the rate of change, M we also call it, is your change in y over your change in x. So your y values are negative 1 minus 3. Be careful with the negatives. Negative 2 minus 4. If you had a negative and it was minus minus, you'd make it a plus. So minus 4, or negative 4, over negative 6. The negatives turn to positives, and then you can reduce by making it 2/3. So our slope is 2/3. Now look at all the writing I did. And I don't have to, but that ensures that I make less mistakes going slow in my steps. So make sure you show enough steps. Here they want you to try. So I want you to pause the video and try the first one and come back and check. Okay, Make sure you label your points x1, y1, x2, y2. I write the formula, I substitute in my values, I simplify, and I'm done. Okay, try the next one. They give you 3 points on the line. Do you need to use all 3 points? No. Pick 2 and try it on your own. Pause the video and come back. Okay, so I chose positive values. You could have picked any 2 that you wanted, but I chose the ones that were positive because they were easy to work with. I wrote out my equation. I said y2 minus y1, x2 minus x1, and then I reduced. So my slope is up 4 over 3. Here's the thing. When you're graphing, you could also say down 4, left 3, because it still gives you positive 4/3. Same thing over here. Up 4, right 1, or down 4, left 1. Be the same thing, okay? So on your next page, it says, what is the rate of change or slope of the linear equation? Oh, didn't we just do this? Yeah, we did. So ignore this part. I got copied to the next page. So we've already done it. Yay. Okay. Example 2. Find the rate of change or slope of the linear pattern equation. So here, these are just coordinates. This -2, 3 is like this coordinate here. This -1, 6 is like this coordinate still. They're all coordinates. So you can pick any 2 points. Okay? And you'd say -2/3. I don't care which ones you pick. I picked a negative. That's okay. -1, 6. And I'm going to say, 1 second. It seems really dark in here. There we go. Let's make it brighter. Okay. All right. And we're going to label x1, y1, x2, y2. Okay. And we're going to graph. I'm sorry, not graph. We're going to write our equation. So it's going to be 6 minus 3 over -1 minus a -2. Go slowly when you're doing this because this is actually going to be positive and your slope is 3. Notice it says, or view the change in y over change in x. The slope is just what happens to all your y's, what happens to all your x's. If you look here, your slope was 3 up and 1 to the right. 3 up, 1 to the right. So you could have done it that way as well. You could have gone, oh, we're going up 3, we're going up 3, we're going up 3, we're going up 3. We're going up 1, we're going up 1, we're going up 1, we're going up 1. Change in y over change in x is just simply 3. Does that make sense? Okay. All right. Let's move on to the next video, or not the next video. Oh, geez. The next example. It says find the value of r so that the line passes through each pair of points. Well, they give us an x1 and a y1. They give us an x2 and a y2, and they give us an m. Rather than guessing or checking or sitting there stuck, what do we know contains an m, an x1 and a y1, and an x2 and a y2, our slope formula? So to write slope formula, m equals y2 minus y1 over x2 minus x1. Do we know what m is? Yes, we do. Do we know what y2 is? Yeah, it's r. Do we know what y1 is? It's 10. X2 is -2, and x1 is 12. So now we simplify as much as we can, and we say -4 is r minus 10 over -14. Well, this actually is technically a proportion. We can put it over 1. So we can use a proportion to solve. 1 times r minus 10 is r minus 10. -14 times 4, it's going to be 16, carry the 1, 56. Add 10 to both sides, 66. That seems awfully high, so let's try this. 66 minus 10 is 56. 56 divided by 14, yep, it's true. Okay, so that's r. They're asking you to solve for what the other coordinate or the y value would have been. Okay, here, same thing again. Go ahead, try labeling this and do it on your own. Pause the video, come back. Okay, so we wrote our formula down. We substituted on all our values. We cross multiplied to create a proportion. We solved and we got r equals 3/4. That's fine. R can be a fraction. Questions? Okay, let me know. Okay, let's try the last one. Go ahead, pause the video, try it on your own, come back to check. So 4 minus 8 is -4. R minus minus 2 is +2. We cross multiply. We're getting a -1 times r plus 2 equals -8. There's just a lot of negatives going on. But it's actually, I think, the easiest problem we've had so far. So we multiply by negative, we have to make sure we distribute it to both pieces. We get -8, add 2, divide by -1, or multiply by -1, and r is 6. Okay, now I want you to do this worksheet on your own. It says examine the graphs below, which have positive slope, negative slope, and neither. Okay, so I want you to try doing 1 through 4 and come back to the video. Okay, so we're going to run into situations where we get 0 over, let's say, 7. If you get a situation where you're trying to solve for the slope, 0 divided by 7 is actually 0. So the slope was going to look like this. If you can write the word 0, you have a 0 slope. Sometimes you'll get where you maybe have like 3 divided by 0. Go ahead and try that in your calculator. What's going to happen? You're going to get an error. So the graph's going to look like this, where there is no slope, because this is undefined. It breaks definition. You're not allowed to divide by 0. Okay? So we'll have negative slopes, positive slopes, 0 slopes, and no slopes. I tell kids that this is okay, but this is not. Okay? All right, it says use the graph to find the slope of each line. So go ahead, pause the video, or I'll show you number 5, and then you pause the video. So AB, so let's go over to AB. Here, we went to the left 2, so it's going to be negative. Okay, we went, well, it depends on where you start, so let's ignore that. If you start from B, you're going up 1, 2, 3, 4. And then you're going to the right 2. So your slope is 2. When I said it was negative, that meant if you're starting from A, you went down 4, left 2, which would still be a positive 2. Okay, it depends where you're coming from. So let's try number 6 together. CD. So if you're starting from C, you're going down 2. You're going over 6. So it equals negative 1/3. All right, pause the video, try the rest on your own, and then we'll come back. EF. Oh, look. 0. 0 slope. GH, you went up 1 and over 1, 2, 3, 4. 1, 2, 3, 4, 5. IJ, you went down 1, 2, 3, 4, 5. And you went over 1, 2. KL, you went down 1, 2. And you went over 1, 2, 3, 4, 5, 6, 7. MN, oh, you went down 1, 2, 3. We didn't go over. So it's like negative 3 over 0, which is no slope. If you just see the no, you can say no slope. Or undefined is really what you're going to see in textbooks. Okay. PQ is, it doesn't matter which one you start. So say you start from here, you go down 1, 2, 3, but you go over to the left 1, 2, 3. So it's negative 3 over 3, which is 1. Or you say, I went up 1 over 1, up 1 over 1, up over 1. All right. Find the slope of each line. Rise is negative 5, run is negative 5. Therefore, your slope is 1. Pause and try yourself. That's it. Okay. I just wanted you to get exposed to some of this. And here, you don't have to do every single one. I'd say pick 3 and do them. All right, so I want you to try, let's pick the bottom 3, 26, 27, and 28. I'm going to show you number 17. Okay, so number 17, you have an x1 and a y1, and an x2 and a y2. So you're going to say 5 minus 9 over 1 minus 3. Your slope's going to be negative 4 over negative 2, or just 2. The end. All right, here, try these 3 on your own. Pause the video. All right, so you have negative 7, negative 11 over 16, and 7/4. Okay, take opportunity of having these videos. Why is this not go away? Okay. Take opportunity of having these videos. That way you can rewind, you can pause. I guess it's not rewinding. I was bored in a way earlier generation. Take advantage of being able to go back and look and hear what I say over and over again, okay? So those are your notes. I know they seem kind of long. However, it's really good practice and you only have 8 homework problems. Check Google Classroom for your homework and email me if you have any questions.